This section's on 8.2 ellipses, so let's go ahead and talk about that. Now, the ellipsis is not the same as a circle, so by definition, there are things that are going to be different from a circle. So just to cover the circle definition, if you remember from geometry, said that if you have a radius, the radius is the same all the way around the circle. Where the ellipse, you can see in this picture, it is elongated on a certain axis, whether it be the x-axis, it's stretched, or on the y-axis it could be stretched a little bit more. So that's why it's not the same as a circle. Okay? So the formula for the ellipse that is longer on the x-axis is this formula right here, which is x minus h squared divided by a squared plus, and then y minus k squared divided by b squared equals 1. It always has to equal 1 for the ellipse. And if it's not equal to 1, then you're going to have to divide the whole thing by it, the number that you have on this side. So that's how we're going to get these fractions right here. Okay? But for the class for practices, we should have equal to 1. When we do the next section, which is then completing the square and things like that, you will have numbers on this side, and we'll have to manipulate it so that way we get a 1. Alright? Things we need to point out on this right here. One of the things is that the long side right here, in this case, is the x-axis. So in the x-axis, that's called the major axis because it's the long side. And then on this side is the shorter axis. And so the y-axis is going to be called the minor axis. We also need to find is the center, and the center, notice, is HK. So looking at the equation, it's the same thing as what we just did in the parabola section. The H and the K's are still with the X's and still with the Y's right there. Okay, so nothing has changed right there. We also have is this thing down here, which is a squared and b squared. You're going to have to take the square root of a and square root of b to figure out the distance. So if you have a number right here, whatever that square root is, once you get the center, you start from the center, you count on the x-axis. So that's the x-axis number right here, whatever the square root is. And then this right here is for the y-axis. So from the center, you will go up and down on the y-axis, the same number of distance. And this is right here, the x-axis. So it's from the center. We'll go both ways, the left and the right as well. Okay? Now, in the parabola, let's think of it as the half of the ellipse is similar to a parabola. So what we have is this right here, the parabola. Notice in the parabola we had this thing called the focus, right? The purpose of the focus is kind of like the center to make that curve. So I would use then like a compass, and from there I would put that in the middle, and then I would start making the curve, and it makes a nice curve right there. Okay? So that was the purpose of the focus. Now, for the ellipse, it's not the same as a circle, because in a circle, I could put my compass down here in the center, and if I rotate it all the way around, it should be exactly the same for a circle. But in ellipse, if you notice that this side is longer than this side, so by definition, you need to have these new things called a foci. Foci is just basically a plural of the focus. So just like the parabola, how we had a focus right there, the purpose of the focus is to draw that nice curve right there. We need it on both ends right here, because this side right here and this side right here has a curve that's a little bit different from where it is up here and down here as well. Okay? So that is the foci. So the foci then is the plus and minus c comma 0 in this case, because the long side is on the x-axis, so that's why we have it on the c right here. And then the formula for the foci is going to be a squared minus b squared equals c squared. Now this looks very familiar. It's like the Pythagorean theorem, but in the Pythagorean theorem it's a squared plus b squared. So don't get it mixed up. This is a minus instead. Okay? So then you have to square root it just like the Pythagorean theorem, and then from the center, wherever is on the longest side right there, you will start counting to get your foci from there. Okay? Now let's go to the other axis, which is the y-axis. Now y-axis is similar to the x-axis. The only difference now is then the y side is the longer side right here. So because the y side is the longer side, we're going to call it the major axis on this side right here. This is going to be the minor axis because obviously that's the shorter side. We still need the center. And so the center is still the h and k, so notice that this h is on this side and the k is on this side. Also, I want to point out, a lot of times what is going to happen is the bigger axis or the major axis is going to be the front part of it, and then the minor will be in the back. Now, not always, because it's a plus, it really doesn't matter, but most of the time, you'll find that this right here is going to be the bigger side versus the other side. Now, if it's mixed up, just look for the number that's on the bottom right here that is the biggest, then obviously that's going to be your clue that that's going to be the axis that's going to be the largest. So in this case right here, the y-axis right here, whatever the square root of a is, we're going to count that up, and it'll find us the a, and the same thing for the b, for the x-axis, that will be the square root of it, and that will give us the b part of it. Okay? And we still have the foci, but the foci in this case, notice it's going to be 0, comma, plus and minus c, because it's the y-axis now. So from the center, we're going to do the same calculation, formula-wise it's the same, but from the center, we'll just move it on the y-axis, because it's the longer axis that we'll be placing the foci instead. Okay, so let's go ahead and do an example. So the example says graph the ellipse, and it says the y squared over 25 plus x minus 1 squared over 4 is equal to 1. And then we're going to go ahead and find the center. So the center is going to be still our HK. So in our case right here, the center is going to be 1. And then in this y, it's going to be 0, obviously, because there's nothing inside the parentheses. So let me go ahead and pull this up a little bit here. Okay, so center is going to be 1, comma 0. And then for the a, so a in this case is going to be the longest side. So in this case, the longest side is the y side, that is the longest side. So square root of 25 is going to be 5. So a is going to become 5. And that's going to be the y-axis. So I'm just going to put y-axis right here just to remind myself when I graph it. I'm going to graph it on the y-axis. And then the b is going to be square root of 4. So square root of 4 is 2. So 2 right here, and that's going to be on the x-axis right there. And then we need to find the foci. So the foci, again, the formula was the a squared, right? In our case, a squared is the 25 minus the b squared, which is 4. So that's going to be then 25 minus 4 is equal to 21. And that's going to give us c squared. So c is equal to square root of 21. And square root of 21 is approximately 4.58, right? So we'll probably have to guesstimate when we do the plotting part of it, okay? And then, so 4.58 is always going to be on the longest side. So wherever the longest side is, that's what's going to go for the foci. So let's go ahead and graph this. So at the center of 1, 0, so 1, 0, this is going to be the center. I'm just going to put a C for center right there. And then on the x-axis, or on the x-axis right here, we're going to go 2. So from the center, we're moving 2 spaces to the left and also 2 spaces to the right. So here we go, 1, 2, so that's a dot right there. And then go the other direction, 1, 2, that's 1 right there. And then the y-axis, I'm going to go 5. So on the 5, from the center again, it's going to go 1, 2, 3, 4, 5. So it's on the tip of that right there. And then we're going to go down 5 from the center again. So it's 1, 2, 3, 4, 5. So that's going to be the other part right there. Okay? So we can almost connect the ellipse right there. So I'm going to just go ahead and do that. It's going to be a nice curve on the ellipse. So try to kind of do it as best as you can to get that curve going. So something like that. Okay. Now, I need to find is the foci, and the foci is 4.58, which we're going to approximate about 4.5-ish when I'm graphing it out. And it's, again, it's from the center. So from the center, I'm counting 4.5-ish, right? And so it's the longest side that's going to become the foci. So obviously the y-axis is the longest side, so we're going to count from there. So I'm going to go 1, 2, 3, 4.5-ish right there. So that's the foci, so I'm going to call it F1 right there. And then we're going to go the other direction, 1, 2, 3, 4.5. So it's going to be somewhere around here, and we're going to call it F2, because that's the foci right there. Okay? So that's the graphing part of the first example. Now let's go ahead and do the example 2. So example 2 now gives us the ellipse. So I'm going to erase this part. So exactly the same thing. We still need all of the details for it. For this right here, the center is still going to be from here. So the x number is going to be 4. And then the y is -3, because in this case it's +3. So if you remember, the formula is always x minus and y minus. So originally this would have had to be -3 because it becomes a plus right there. So that's the center. So I'm going to go ahead and write the center at 4, -3. So 4, -3. And then for my A, so my A is the longest side, so in this case, the longest side is underneath the x-axis right there. Square root of 9 is 3, so we're going to put down 3. And again, I'm going to put x-axis just to remind myself when I graph it, that's the longest side. And then the y-axis is square root of 1, which is 1. So that's going to become 1 right there, that's the y-axis right there. And now we do the same thing, we want to find the foci. So the foci is going to become c squared, right? Is equal to a squared. So in our case, a squared is going to be 9 minus 1, which is 8. And square root of 8 is approximately 2.83. So 2.83. So when we graph it out, we're just going to make it a little less than 3 because it's about 2.8, which is what we're going to graph. Okay? So now we're ready to graph it. So at 4, negative 3. So here we go. 1, 2, 3, 4. Negative 3, 1, 2, 3. So here's my center right there. So put a C for center. And I'm going to go 3 on the x-axis. So 1, 2, 3 on the x-axis on the right-hand side. And then going the opposite direction on the left. So that's 1, 2, 3 on the left right there. And we're going up 1 and down 1. So from the center again, from up 1 and down 1 right there. Okay? So the ellipse, you can see, is kind of a bit smaller just because the numbers right there were smaller, the 9 and the 1. Okay? So we're going to try to make it as good as possible. The ellipse right there, something like this with a nice curve. Okay, something like that. And then we found the foci is 2.83, so again, the longest side. So you can see the longest side is on the x-axis. So from the center, we're going to go approximately 2.8. So it's going to be 1, 2.8-ish, somewhere around here. That's going to be my F1. And then do the same thing, 1, 2.8-ish, somewhere around here. That's going to be my F2 right there. So that's going to be my foci right there. Okay? All right, now let's try the next one, which is then going the opposite direction, saying that if we have this graph, how do you write the equation up? So I'm going to erase this right here, pull this down so you can see this better. So in this equation right here, or writing the equation, we are given an ellipse. The y side is the major axis right here, as we can see. The x-axis is the minor axis, as we can see. This is 5, 13, 5, 3, with a center of 8. And then on both ends right here, we have this 2, 8 and 3, 8. I'm sorry, 8, 8 on this side. Okay? So if the y-axis is the longer side, we're going to obviously have the y first. So my equation is going to look something like this. Y minus k squared all over a squared plus x minus h squared over b squared equals 1. So I need to figure out is where my center is, because then I can substitute my center number, which I already know because they gave us at 5, 8 is the center. So we're going to use that for the substitution. Now the A and B is a little different from what we did on the other ones. So the other one, they gave us a number like 25, right? And you have to take the square root of 25, and then from the center, you count the distance, right? So in this case, since a y was underneath it, 25, you count from the center 5 spaces up, 5 spaces down, okay? Now, when you have to write in the equation, it's a little bit different mentality. So here's what we're doing. We're finding the distance of this, kind of like the focal width that we did in the parabola section. We're going to find the distance. So at 13, the height of 13 and the height of 3, the distance or the difference between that is 10 right there. Okay? So 10, half of 10 is 5. So when we write this equation up, let me just go ahead and do the skeleton of this equation. We're going to put 5 into the bottom part of this right here. It's going to be 5 squared right here. Okay? And then the center, I'm going to go ahead and put the center in. So it's going to be y minus 8 squared plus x minus 5 squared equals 1. And then I just need is the denominator for the x. So same thing with the x. It's 2 on the x on this side and 8 on this side. So the difference or the distance between that is 8 minus 2, which is 6. Half of 6 is 3, so we're going to put in 3 squared for that. Okay? Now, the reason why it's a little different is because remember, we have the center. We know the center is 5 and 8. So if I start at 5 and 8 right there, right? And if I have 5 on the y, I'm going to count 5 spaces there. And it should give me the 3. So in this case, we're going to have to subtract because 8 is bigger. So if I go 8 minus 5, that should give me 3. And if I go 8 plus 5, that should give us the 13 that we need on the top right there. Okay? And then going the opposite direction, on the x-axis, if it's 3, you go from 5, you add 3, that should give us 8, and if you subtract 3 from 5, that should give us 2 right there. So when we write up an equation, it's a little different. You have to find the difference or the distance between it, divide it by 2. That would give us the number right here, and you put the squared. Okay? Whereas the other direction, if they gave us a number, you would have to take the square root of it to figure out what the number is down here. Okay? So that's going to be the classwork for the ellipse, is writing the equation and also drawing the equation out.